Alright, welcome. Today we're going to be talking about servos. We got a really cool project or series of projects that we can utilize with servos. So we're going to just do the basics in this one. I'll show you how they work, and then we'll start adding things with servos. So let's get ready. I'm going to switch screens. First off, let me point out kind of how servos work and how they differ from other motors. Let me put the dial down and clear space here. This right here is a typical motor. If we apply some current to it, then this will just rotate around and around and around, continuously going around and around, which is useful. But sometimes we don't want it to just spin. I mean, this would be great if we hooked it to a wheel and then the wheel will spin and we can get some motion like that. But sometimes we want to get something that will get some more control in how much the thing turns. So we'll get that with a servo, which is this part here. And with this, we can control how much this horn, I think that's what they're called, how much they turn. And this one will rotate 180 degrees, and we're going to show you how that works. The end does pop off, and sometimes there are other little attachments you can put on here. I don't have any with me. Actually, maybe I do. I can show you. Yeah, so sometimes they come with other little attachments that you can push on the end here. Oh, that one doesn't fit this one. Well, these are really tiny compared to the other one. These are really tiny. Let me look around if I don't see something really quick. Well, I'll just show you anyway, even though these go to a tinier servo. But you'll get the idea. We have this little guy right here. We have this round gear. We have options that we can hook to the end of the servo we can hook these to other parts and get them to move. We're going to use, I think, this one today. So I'm going to push that one back on. And this one I'll put back in its bag. Alright, get back in there. And that one. Okay, one more little part. Okay, so here's the parts, the two parts we are going to use. We're going to have the potentiometer. We're going to use this to control this. You've seen this part before. We've used it to turn on RGBs to different colors. Now we're going to get it to control the amount of turn on our servo. Now you might use a slightly different one with the black knob. It doesn't really matter. These are really nice variable resistors. And other than that, we're going to need a bunch of wires, which I have off to the side. On my Canvas page, I have a little illustration here showing us what the different colored wires are for, because on the servo, let me take a peek. Now look at that, I have a wire rammed in there, yanked out. Let's pull that out if I can. Yeah. Teeth? No, I don't want to use my teeth. That's going to be a problem. So I pulled that out. That means one of my wires, I ripped the end off of it. Looks like it was that one. I tore the end off it. We were going to throw that away. No big deal. Alright, so we got these three different colors, and we need to know which one goes where. And we look around the servo, and I don't see anything on here that tells me what each color does. I know one is probably for ground, one's probably for 5 volts. We've seen that lots of times. And one is probably a signal. Which one is which? Even your teacher, Mr. Brower, has to look these up. I mean, I have a sense that the red's probably going to be the 5 volts and the brown is probably ground. But I'm usually not 100% certain, so I always go online and I can look up these images here and quickly get reminded of which color goes where. So the ground is the brown one, and the red one is our 5 volts, and our orange is going to be our signal wire, and it's suggesting we must use a PWM. This is one of those digital pins that have a squiggly line next to them. Maybe I'll show you what that looks like. It is, get a little wire here to point with. It's 9 of them has one of the little squiggly lines next to it, 10 has one next to it, and 11. PWM stands for pulse width modulation. It's basically a digital output. All these are digital outputs. They're on and off, but we can make it act like an analog, which is over here. So it's a digital that's going to act like an analog. And the way we do that, I won't go into too much detail, but we're going to turn the on and off really fast. And so we need to be mindful of that, making sure we get it in the right pin over here. All right, what I think we'll do though is we're going to start with the potentiometer. We're going to wire that up, make sure it works, and then we'll add the servo. So let's go ahead and do that. I'm going to move the breadboard in here, and let's just pick right there. That looks good. So one side of our potentiometer or variable resistor needs 5 volts. I'm going to pick that side, and we're going to send it to 5 volts on my Arduino. Way up top there, plugged into 5 volts. I'm going to take the other side, and we're going to plug that into ground. Now there's a ground on this side, and there's 2 on this side, and I'm going to, let's just put it over here. Over here next to the 5 volts. So I got one of them in ground, the other one in 5 volts. And the middle one is our signal, and if I can get in there, I'm going to push it into the center one. Move these out of the way. And this is going to be an analog. We're going to put it in A0. I could pick any of these. A0 through A5. I'm just going to pick A0. Alright, maybe I'll flip that around so you can see him a little better. Okay, so let's set it up so we got that much working. Give us a little space here. To see that it's working, we need some feedback. So we're going to use the serial monitor, our good friend here. We'll turn that on with the serial dot begin. 9600 is our baud rate. Got to make sure that matches our serial monitor, which is the default speed, so we're good with that. We need to store a value we get from the potentiometer, so we need to set up a variable, which is going to be a whole number, an integer. So we're going to make up a variable. Let's call it pot pin, so I can remember what the variable stands for. So pot pin. We're going to collect what we get from the potentiometer. We're going to store it as pot pin. So in a analog read, we're going to read that value, and we use pin A0. We could use any of them ones from A1 through A5. I used A0, and now we're just going to look at it and make sure it's working properly. And we'll just say A0 equals, probably don't need to have all this fancy stuff in here. And then we'll put in pot pin. Alright, so we're reading the analog pin A0 and we're storing it as pot pin, which is an integer. And then we have a little message that's going to come up on the serial monitor. It says A0 equals, and then it won't drop to the second line because ln is not there. It'll just put in the value for pot pin after the 0, and then it'll drop to another line. ln, after it puts this in, the next serial print we do will be dropped to the second line, the line beneath it. So let's give this a try. I need to plug my Arduino into the computer. So let's go ahead and do that. I'm going to flip this around. That'll be pointed towards my computer, and I won't have all this nest of cables in the way. Alright, just move that over here. Reset things. That looks pretty good for now. And we're going to make sure it's found a port for us. The board looks good. It's Arduino Uno and it's COM18. And I think we're ready. Let's upload this. You're going to want to save this. If you want to keep working on it, give it a title. I usually skip this part, but maybe I want to call it Servo. This time, usually I just skip it. Oh, made a folder for me. That's why I skip it, because it hassles me. Waiting here, while we're waiting, let's get a little squeeze. Alright, you can do it. A green line. It's almost there. And it's done. Open up the serial monitor. One thing I should have put in here, I should put in a delay, because now it's just vomiting numbers on us, but I'm not going to go back and do that. Let's just reach over here and turn it and see if it goes down to 0. I'm slowly turning the knob, and yes indeed it is slowly moving down to 0. Nice. So our potentiometer is working fabulous. Now we're going to move on to get the motor out of the way. We're going to take a look at our servo. You gotta remember what pin goes where. I'm going to actually, I've got a red one in front of me and a black one and my favorite yellow signal wire. So let's move these out of the way just a little bit so you can see what I'm doing. Looking for that brown one. I'm actually going to just shove it into the pin right here like that. So my black one is going to be my ground. And it's kind of loose, but I think it'll stay in alright. The red one, actually while I've got it in there, let's just put it right into the Arduino. It needs a ground. There's one on this side. I'm going to put it in right there on that ground pin. The next one over. Be mindful that these do sometimes fall out. If I wanted to keep this project for a while and use it for something, I definitely want to put some tape over this, but we're not going to worry about it. But it could be a problem. You find that something happens, this could be the reason. That one actually went in really tight. The black one was not so much. Alright, so this is our 5 volts, and there's only room for one 5 volts, so guess what I'm going to have to do? I've already got the potentiometer pin in the 5 volt one, so I'm going to have to pull it out, and we're going to have to make a, matter of fact, since we're going to do that, let's do it for both the ground. I'm going to pull all these back out. Let's go ahead and make the red rail positive by grabbing our 5 volts and moving it over to that rail like there, and then we'll plug in the 5 volt and the 5 volt for our servo, all on that same rail because I ran out of room. Alright, so I got that part done. Let's do the same thing for the ground. Let's take our ground wire right next to it. We're going to put that into the blue rail. So that whole row next to the blue line is our ground, and then I'm going to transfer the potentiometer wire into that. And the same thing for the servo. I'm going to put that anywhere along the top row next to the blue line. Alright, so I got 2 of the 3 wires in. The last one, my signal wire, you have to be careful. This one needs a PWM. That's a digital wire with the squiggly line next to it. So I push that in here, and I'm going to go over and let's use 9 for that one. Alright, so I put that one in pin 9. I think we're ready to go. That should be everything we need. It's a little bit of a mess there, but that looks pretty good. Move this over so we can see everything. And I'm pondering whether I should do this on Tinkercad as well, and you have less wires kind of messing around. Should we do that? You could always skip that part. This one doesn't, I don't think this is that hard of a wiring that we need the Tinkercad. The Tinkercad will just clean this up a little bit so we can see where things are heading a little better. Yeah, I think this is simple enough that we're not going to worry about that. So let's go ahead and go back to our code. And servos, like some other complicated parts, they have a library we can use to make our life easier, and so we're going to, this is a standard library, it's not one that we have to install. So we go to include library. This first batch are very common libraries, they're already pre-installed in Arduino, and we're going to jump down to Servo, and that'll install our library for us. Now typical with libraries is usually we have to make a variable name up for attaching things to our Servo library. So we can use any name you want. Let's do like a ham sandwich. Ham sandwich, how about that? Now probably a better word would be like my Servo or something like that, but I just want to emphasize that we're making this word up to help our library out. It needs a variable that we define. And as usual, we need to set up one more thing. I'm going to move that over a couple spaces. This is my Servo. We need to tell it what pin we used. Actually, I just made an little error. I went back and used my Servo, and I just called it ham sandwich. Whatever I call it here, I got to make sure I use it right there. My Servo is probably a better name overall, but let's keep with the ham sandwich, just to be a little silly today. We used pin number 9. Took a little peek down there. That was their PWM pin, and we should probably, let's see, I think that's all we need there. Let's jump down and let's gather, or what do I want to do with this? We got a variable for the pot pin, and we're going to use that to move or to cause our servo to move. Now our servo, it moves about 180 degrees. So it likes to, we're going to use a function called, I'll type it in right now while I'm thinking about it, servo right, and we'll put a parameter in here. Inside of this parameter, this will be a number between 0 and 180, and that's what our servo will turn to. Think of it as degrees. And I'm trying to think of a way to ease our way into showing you how this works. Maybe, I don't know, I don't think this part is that complicated. What I want to do ultimately is take these pop pin values and just put them into my servo. See, I did it again. I'm just stuck on my servo. But I think that's actually a good thing that I'm getting stuck on this, because to really emphasize that if I use ham sandwich, I got to make sure I use it everywhere. Ham sandwich, ham sandwich, ham sandwich. I am making up that word, but ham sandwich is a really unusual word for me. But I think that really illustrates a point here. So let's go ahead and actually put this value right into here. The only problem we're going to have is this value, as we saw on the serial monitor, it gives us values between 0 and 1023. And this ham sandwich right, it's only going to accept 0 to about 180, and it won't understand what's happening after that. So ultimately, we're going to need to write in, we need to convert the values of our pot pin from 0 to 1023 to 0 to about 180-ish, depending on the servo. Some servos are, you can get a little more movement out of them, but this one is going to go about to 180. So I'm going to teach you a new function. Let's go and do that. It's called the map function. Now we could write a little equation actually. I don't know what math class you're in, but we could actually do this mathematically, but map function is going to be a whole lot easier. So let's go ahead and do that. The first thing the map function requests is it wants to know what number we're actually going to be rescaling. And we're going to rescale the pot pin. And its scale, it wants to know what its scale is. It can expect that's 0 to 1023. Then it wants to know how we want to rescale it. And we want to rescale it from 0 to about 180. I'm a little hesitant because if you get the wrong number, you're not going to break anything, but you might get a little angry and make some noises if we stress it a little bit. But I think we'll just start with 180 anyway. Alright, and then for the ham sandwich, which is our servo, we're going to write the value we just mapped, and we're remapping this. We need a new variable to map it to. So let's make something else up. If we do something weird like can't say ham sandwich again, but as you saw, Mr. Brower gets thrown off when we use weird variables. So maybe we should go back to let's just call it ham. Stay with this weird thing we got today. So we're going to rescale our pot pin value from 0 to 1023, and we're going to rescale to 0 to 180, and it's going to store it as ham. And then we're going to put that value into our servo, and it should turn. So let's give that a try. I'm wondering if we should throw a delay in here. I think we'll leave it out. I don't think we need a delay. If we're looking at the serial monitor, we might want a delay because the number is going to be spit out really fast, but I think it will actually work better without a delay. So let's get rid of some space there and give this a try. Everything was set up already. Give it a moment here. Give a little dyno a squeeze for good luck. That should be our good luck dyno. Give it something to do while we're waiting for our sketch to compile. It's got to look it over. What it's doing is looking over, make sure it understands everything. It'll tell us if we have any errors. And it's got to translate this into a language that the computer understands. Alright, come on, you can do it. Sometimes when it goes slow like this, that means there's an error sometimes. But most of the time, we're just waiting and we don't know why. Alright. As usual, information always is kind of interesting here. The Arduino doesn't have a whole lot of memory. We just used 9% with this little bit of code. 3,138 bytes, 32 kilobytes, or 32,256 bytes. Alright, I'm going to open up the serial monitor and turn the knob at the same time. If I can reach over here, show you my servo while I'm turning the knob. on the potentiometer. All right, let's check that out. I'm going to tilt it upward. I'm grabbing the knob and I am turning it. Notice it is rotating not quite 180. I have it going to 180. It's not quite reaching 180. I'm curious if I went higher than 180. Should we do that little experiment? You'll also notice that on my serial monitor, I only have information about the pot pin. Should we just add in another line for this mapping function we just used so you can see what's happening? I say yes, let's do that. Let's take a look at what our map did. So map equals, and let's put in map. Whoop, not map. What am I doing? We had ham. We called it ham. Okay. Should I call that ham over here or just leave it as map? This is, I'm referring to the map function. So the first line we're reading and we stored as pop pin and we're seeing that on serial monitor. Now we did this little rescaling and we're calling it ham, and I want to just take a peek so you could see what was happening. And then I'd like to tease this one up. I'm curious to see, well, let's do one variable at a time. Change one thing at a time. I want to see if we could sneak it up to 200 or a little higher. We'll wait here a minute. Squeeze the brain this time. This was hard to squeeze. It was easy. Uploading, almost done. Alright, let's take a peek. That is super fast. Now we need a delay. So let's throw it in. I think it is worthwhile to see this. Not take my word for it. I'm telling you what's happening, but I think it's really important to see what's happening. Unfortunately, we had delay. We got a little slow today. Are you curious to know why sometimes it's slow to compile this and other times it's super fast? Alright, here we go. Okay, we slowed down. We're at 180. I'm going to turn the knob and show you that, yes, indeed. Let's go back to the top here. So here's my raw reading, 1023, and I've remapped it to 180. So ham is indeed 180. I've taken those pop pin values, rescaled it to 180. So we're going to, now we'll turn it and have it go down, back down to 0. Okay, that's how the map works. I'm going to take out the delay this time though. And technically, I mean, write this program, do we really need to see with the pop-in values? No, that's really instructional information, diagnostic to make sure things are working. It's not necessary to get the servo to be moving. But we're going to leave it in there, go back to everything working in proper order, and then we'll end this. Future projects, we're going to use this servo to do other things. Alright, it's done. Right now it's not doing anything except just turning like that. That's 0. Let's see if it goes 180. Not quite. I'm going to do one last little experiment with you, if that's alright. I really want to turn this, to crank it up to like 200. Well, let's make it more obvious. Let's do like 250, see if it gets angry at us. There's lots of different servos, and sometimes you go above a certain value and it just gets angry. Starts making noises. This one has been a happier servo. So it'll amuse me just for a moment. Or you can just skip this part. Of course, I always encourage you to make some modifications yourself and see what happens. Right now we're at 250, and I can hear it clicking a little bit. We're at 0. I'm going to pull this out and make it more like a 0 angle, and then I'll turn it again. See what happens when we go to 250. Now it's angry. We're getting less turning from there to there. Yeah, it didn't seem to have any effect. So going above 180 is not giving us more turning radius there. So when we use in the future, we'll stick with 180. Not 2,100, but just 180. Anyway, I'm just messing around here. I think that's good enough. You understand how servos work, the little library we need, and a couple of little parts to get it to work. And that is it for this project. We will see you with the next one.